All right, what's up, everybody? So we are going to continue into a new unit based off of symmetry and linear programming. Going to go back, if you didn't watch the average rate of change, the end of that video last unit, make sure you go back and watch the end of average rate of change. It's posted on YouTube. It's posted from last week as well. So make sure you are going back and looking at the second half of that lesson so you get the review on average rate of change. So today we're going to run through even and odd functions and then some basic transformations. Again, just kind of hitting it. We've talked about transformations a whole bunch, so it'll just be kind of a quick refresher based off of functions. So looking at this, we got two types of functions. We call this symmetry. We got even functions and we got odd functions. So an even function is symmetric with respect to the y-axis. Oh, let me get that. Well, this means you could fold the graph on the y-axis, so you fold it in half and it would line up perfectly on both sides. Odd functions are always symmetric with respect to the origin. So remember that point is 0, 0. So this means we can rotate the image upside down and it will appear exactly the same. So you can turn your sheet of paper upside down and you are good to go. And if we cannot classify the function as odd or even, then it will be neither. So directions here, determine graphically if possible, or using possible symmetry. So determine graphically using possible symmetry, whether the functions are even, odd, or neither. So if we're looking at this one does not go through the origin. So if I spin it upside down, it moves it to the left side. So you can physically move it. So this one is actually neither. If it went through the origin, it's got a good chance of being odd. So this one right here, I see if I draw a line down the middle here and I fold it on that line, I get these same things. So this is what an even function looks like. Come over to 3, same thing. I got my y-axis. If I fold it across the y-axis, this one is also even. So we're just looking for symmetry. It can be either even, or it can be odd, or it can be neither. This one right here, if I draw a line down the middle and fold it, it doesn't work. But if I rotate it upside down, and I'm physically spinning my iPad while I'm doing this, so you can double check, you just can't really see that, this would be an odd function. Same thing over here. If I rotate this one upside down, this would also give you an odd function. This one right here, even's easier to check because I can't fold it across that line. If I rotate it upside down, it goes down. So this is an example of neither. So just looking at your symmetry, you got odd. If you rotate it upside down, it looks the exact same. If you got even, if you draw a line down the y-axis, you get the exact same thing if you fold it over that line. And then neither is obviously neither of the two. All right, let's take a look at this. So we just looked at graphically, now we're gonna look at algebraically. So to see if algebraically, if a function is even, odd, or neither, we're gonna prove the following. So the first one, to see if it's even, our original function will equal f of negative x. So what this means is you replace every x with a negative x. So if you replace every x with a negative x, the right side of the equation of an even function does not change if that x is replaced with a negative x. If I come over here to odd, f of negative x is equal to negative f of x. What that means is you distribute a negative 1 to the entire function. So every term on the right side of the equation changes its side if x is replaced with negative x. All right, so let's take a look at these. If neither of the above are true, we call them function neither. So function notation, f of x, that repeats the whole original function. So I got f of x is equal to x squared plus 3x plus 5. So f of negative x, I'm going to plug a negative x in for every x and then simplify. And I'm going to check to see if it matches the top. So that gives me a negative x squared plus 3 times negative x plus 5. So that gives me an x squared, because negative x times negative x is positive x. This becomes a minus 3x. So since this does not match this, it's not even. And that's because of that negative sign right there. All right, let's look at the next one. If I say negative f of x, so I got negative, and I got x squared plus 3x plus 5. So I'm going to distribute this, so that's negative x squared minus 3x minus 5. And I'm going to compare this to this equation. That's not the same either, so it's not odd. So this one is a neither function. And that's how we're going to check it algebraically. So let's take a look at a couple here. I want to see if this is even, odd, or neither. So first, let's check f of negative x. So f of negative x is equal to negative x cubed minus 6x. Well, 6 times negative x here. So cubes don't change it, so I got negative x cubed, and that becomes a plus 6x. So since that does not match that, it is not even. All right, so now let's check negative f of x. So negative times x cubed minus 6x. So that gives me negative x cubed plus 6x. Check these. Do those two match up? Yes. So this is odd. So f of x is odd. And that's how we check it. So we always start, we plug in negative x, see if it matches the original. If no, we go to the next one. We distribute a negative. If it matches the f of negative x, then we are good to go. So let's look at this one. We always want to check even first. So g of negative x is equal to negative x to the 4th minus 2. So since they're both even exponents, we're good to go. This is even because those match there. So g of x in this case is an even function. Cool? That's what we got there. All right, quick run through for your transformations again. So we use transformations we already know, just in a little bit of a different format. Nothing crazy. Remember, function notation is anytime you see an f of x or a g of x or an h of x, whatever you want to call it. Absolute value, remember, if a is negative, it's a reflection across the x-axis. If a is not 1, vertical stretch by a factor of a. Horizontal shift, positive left, negative right. Vertical shift, positive up, negative down. Function notation, you got this. So what we're looking at is just a different way to write it. So if this is my original formula for this, I can see right here, here's my negative 2. So it's a reflection since it's negative. Oops, and then it's also vertical stretch by 2. Remember here, it's a negative 1 on the inside, so that's gonna move it right 1. And then it's a plus 3 on the outside, so it's gonna move it up 3. So it's just kind of looking, make sure you got your stuff down. So it's taking function notation and actually looking at transformations. So you can get transformations really easy looking at this. So if I'm going back over these, this negative 4 on the outside is a reflection over the x-axis. And it's also vertical stretch by 4. Plus 3 on the inside means it's going to go left 3. We should be very good at these now. Plus 2 on the outside means it's going to go up 2. So it's just taking what you know and just kind of applying it to a different way. So 2 times f of x minus 3, so I got the 2 on the outside, so that's a vertical stretch by 2. I got the minus 3 is not in parentheses, so that's going to shift it down 3 units. I'm going to skip 3, I'll come back to it. It's the same thing, I got a negative on the outside, that's your reflection. And then I got the minus 7 is on the outside, so that is just going to be down 7. It's not on the inside, it's on the outside. Coming over here to 3, I got 1/2, so that's a vertical stretch by 1/2, or you can call it a vertical shrink because it's gonna smash together. This 5's on the inside now, so that's gonna shift it right 5 units. So write the function, what we're doing here. So let's kind of take a look at this. I'm gonna go ahead and write my f of x. I don't know what it is, so I'm gonna go ahead and keep some space. So reflection across the x-axis, that makes it a negative on the outside. Vertical stretch by a factor of 3. So that's gonna put the 3 outside because it's stretch. Stretch is on the outside. Shift left 1 horizontal, so that's gonna be opposite, so +1. And then down 1 at the end, and you are good to go here. So -3 times f of x plus 1 minus 1. All right. I hope this helps. You got your different way to write transformations, and then make sure you know how to solve your even and odd algebraically. And the method to go there, we always do even first and then odd second, because you check the odd with the even. Make sure you're doing your algebra correctly. And then also go back and double check that you know how to get even and odd based off of their graph. Remember, even is symmetric over the y-axis and odd is symmetric about the origin. So hope you have a wonderful day. Make sure you're going through and practicing tomorrow. Make sure you're also going back over last week's average rate of change at the second half of a lesson, and make sure you have all that information down. So hope you have a wonderful day, and I'll talk to you later.